Okay, so hi there everyone. Thanks very much for coming to a development conference and then actually coming into the room that's not about development. I was super nervous that there would be no one here, so this is already a huge success. This is quite exciting because this is the first time that Voxxed Days Singapore have actually done a track which is on non-technical topics. The Way We Work is the name of the track, and that's what I'm going to talk about today, the way we work, and in particular I'm going to talk a little bit about DevOps and what DevOps means, particularly for engineers and people who build things and teams who build things. So, who am I? I work for a management consultancy. So I'm a technology consultant. I work with I've worked with teams across the world, teams who are building and engineering things. I work for McKinsey Company, which a lot of people think is suits and PowerPoint. It is mostly suits and PowerPoint, but we do lots of other stuff as well. So if you're on the technology side, it's probably more like this. This is doing deployments in airports. That tends to be a lot of my work. I find myself coding in airports a lot. So yeah, I've worked across the world with different clients. I've worked in America, in Europe, in India, across Southeast Asia, and we do a lot of projects where we work together with clients building things, building engineering teams, building products, building services. So what am I going to talk about today? Today I'm going to talk about DevOps and culture in particular. A lot of people, when they talk about DevOps, they immediately start thinking about things like CI/CD, technology, build pipelines, and so on and so on. And that's a really important part of DevOps, but it's a small part of it. The big thing about DevOps is the cultural aspect. And that's what I'm going to go into. And I thought to try and make this a little bit more personal, I would explain, why does this actually matter to me? Why do I care about this enough to talk to people about it? Well, like many engineers, I love building things. I love creating things. I love working with code. If I'm behind a screen, behind a terminal, I'm probably pretty happy. In fact, you could measure my happiness through the day by what proportion of the day I'm behind a terminal. If it's a terminal, I'm happy. If I'm in a meeting, I'm probably less happy. But it's a big part of what we have to do. And DevOps and this cultural aspect is all about making the environments that we work in better for people. Environments where people can do what they're passionate about. Environments where teams and the people who work on teams can work together to build better things. And it's also about eliminating conflict. A lot of organizations, particularly large organizations and enterprises, they have structures which are filled with conflict, and they can be kind of miserable places to work. One of the things that we do when we work with clients is we see this a lot, and we try and look into ways to eliminate some of these sources of conflict. So that's why DevOps is important to me. But before going into kind of what DevOps is and why potentially it matters and why you might be interested in it, I want to talk briefly about the problems that DevOps exists to try and solve, because nothing's really important unless it's solving a problem. We don't come up with concepts or philosophies just arbitrarily. Normally there's a reason for this. So I was trying to think about, where does this come from? So I think it's this. We've got better at building things. In a very, very simple way, all of this DevOps, all of this agile, all this kind of process stuff has become a consequence of the fact that we've got better at building things. And I was trying to think of things that would relate to people at a technology conference, and I jumped onto computer games. Did anyone ever play this game? It's great. Really old, like 2002 or something like this. You just build a bridge and you move your little train across the bridge, and if you build the bridge badly, it falls into the water, and it's great, and it probably represented a large part of my 2000, 2001, 2002. It's probably why I didn't do so well at university. Building software used to be a lot like this. When you're building a bridge, you know what it is you're making. You know what the problem is you're trying to solve. You know the materials you're going to use to construct the bridge. You know the weight of what's going to go over the bridge. You know the teams you're going to use to build it. The use case for your bridge is not going to change. When you have built the bridge, you will certainly have to do some kind of maintenance and keep it stable, but you're probably not going to change it from a bridge into an airport overnight. And this is what classical engineering and classical software engineering and classical software architecture was like. We would know what we would build, we would put together a plan, and we would build it. This is how software engineering started, And in many ways, that mindset of plan, design, and then build is something that's stayed with us up until now. So here we go. Classical engineering is a bit like building bridges. The requirements for a bridge are very, very, very static. We have a well-known strategy for building a bridge. Once you've built a bridge or a number of bridges, you can follow that strategy to build another bridge. The strategy will still hold true. When you build a bridge or any complicated machine, you need to plan very well because changing halfway through can be very expensive. If I start building my bridge from wood and then I realize halfway through that because I actually need to move oil tankers over it, wood's not going to be strong enough, that change is catastrophic. So we need to plan for that very carefully. And because of that, we often end up with a very, very detailed roadmap. And in this world of classical engineering, one of the things that managers or leaders will often be aware of is that they need to have effective management and effective planning. That's how you ensure success. You plan and you're very careful. But software development and the world of engineering for us is actually nothing like building a bridge. And even the term architect, which we use in software a lot to represent someone who designs systems, is a terrible word. Architects build bridges, but what software architects do is they build cities, or they're city planners. So this is SimCity. This is much more like what we do. When you're planning a city, in SimCity, for example, you will think about growth. You might think about zones, like over here I've got a kind of green area where I know I'm going to put some residential stuff and I'm going to put it near the water and I'm probably going to get some pipes and roads and so on. City planning is a lot more like what we do in software. We create spaces for people to put in their constructions. We create infrastructure to connect things together, but we're always expecting growth and always expecting change. And even a lot of the terminology of city planning, hosting, zoning, infrastructure, traffic, is actually much more familiar to us in the software world. And cities never stop growing. They constantly change. We tear parts down, we rebuild them, we change them, and so on and so on. This is much more like what we do. Sometimes this is called evolutionary architecture when it's applied to software. That was a term coined by ThoughtWorks. And in this world, you have dynamic requirements. There are not necessarily perfect strategies that you can follow. You need to test and you need to learn. In this world, you have to be flexible because you realize that change is inevitable. You often don't have a very, very detailed plan. You will often have a progressive refinement plan, which is, if you're in the world of agile, you might have a backlog where the stories that are coming up are very well designed, and the stories that are further down and perhaps lower priority are maybe not so well defined, and you refine these progressively. And in this world, less important than effective management is often effective engineering and effective change control. So this is now the world of software development. Requirements are changing and we're getting better at building things. We've gone from static requirements to dynamic requirements, well-known strategies to test and learn. This is now the world we're living in, where things are much more fluid and much more changeable. There's actually a very, very good distinction which is sometimes used for this. And this is complicated versus complex. Has anyone ever seen this distinction before? Has anyone ever seen the distinction between complicated and complex? That's interesting. It's a very subtle one, but it's very important. Complicated systems can be made of very, very small parts, very, very complicated parts. Building a rocket to go to Mars is a very complicated endeavor. But these systems are very deterministic. If I'm going to build a rocket to go to Mars, I can think about the materials, I can think about the plan, I can meticulously design the rocket, and I can build the rocket. Now, of course, there's going to be change, there's going to be experimentation, but to a large degree, we understand the problem domain. Complex systems are often made of many, many parts, sometimes simple, but with relationships between them. And complex systems are incredibly difficult to plan or predict how they will behave. Organic systems, social networks, computer networks, all these kinds of things are systems that are complex. No matter how much we try, we can't fully understand how they will behave until we see them in action. Economies are like this, lots and lots of different systems. As people move towards, to use a technical example, things like microservices architecture, we realize we're in a complex world. The relationships between different services, the relationships between different components will often expose very, very unusual things. As we start to think more about designing for our users' needs are changing. So what we're designing for is changing constantly. And then as we build something and our competitors and our contemporaries build other things, that's also changing everything. So we live in a highly changing world nowadays when we're building systems. When you're building, we have Gojek here later on. They're building systems that are just changing constantly. The environment's changing. Whereas if you're building, say, an old-fashioned banking system, you know what you're building. It's going to be sort of a ledger and a facility to move money. Nowadays, we're building something that's very, very different to that. Just restart my timer. So for people who are leading, and I'll mention this briefly because I'm assuming that a number of the people who are here are possibly more leading teams or working on the leadership of teams. There's a whole different way of leading when you're dealing with complex systems. A lot of this is about giving teams authority and autonomy. Rather than being prescriptive about what teams do, you have to be more prescriptive about the roles that people play, but allow them to fulfill those roles. You need to allow teams to build strong relationships with each other so they can understand and they can communicate. You need to build communities and you need to build environments where you can test and you can learn and you can adapt. And this is very, very different to classical ways of building systems. So to deal with complexity, we need to make changes. When we don't understand exactly the nature of the system we're building or the nature of the use cases or how it's going to work, we need to get good at changing. Because it's only by changing and learning and testing that we can get better and better at building these systems. And we've actually, we've got quite good at that. So over the years, even, in the last decade or 15 years, as engineers, we've got very good at building things faster. We've got very good at writing software that allows us to build things more quickly, create things more quickly. We don't need to use punch cards. We can, as we saw in the keynote this morning, you can build entire environments in seconds on the cloud. So we've got really, really good at building faster. And we kind of shot ourselves in the foot there. I probably shouldn't say this to many people, many of whom might be leaders, but as engineers, we've shot ourselves in the foot because this is what happens. You build things faster and everyone's really pleased. And then yeah, that's great. And then their expectations are higher. But those higher expectations then become higher demands, and then you have to build things faster, and everyone else builds things faster. So it's change, constantly changing, setting higher standards. Suddenly everyone's saying, well, this company over here can do it in 2 days, and this company can do it in 2 hours, and this company does deployments 400 times every minute, and this company has deployed 4 million times every second. So constantly setting the bar higher and higher to make changes, which can make life difficult for us. So as we have got into the mode where we make changes much, much more quickly, we have started to uncover lots and lots of systemic problems. So going back to where we started, the situation we're in is that we've got better at building things very, very quickly, making lots of change, and we need to make lots of change. But the complication here, and this is what I want to focus on today, is that in many organizations, particularly traditional organizations, change causes conflict. And in some organizations, change is almost inevitably designed to cause conflict because of the way the organization is structured. And this is what the DevOps patterns and practices and thinking is designed to try and solve. So I'm going to go into an explicit example of this. Here's the development team. I've illustrated with bricks, building something. Your development team is responsible for building new products and services. They are assigned to build things. That's what their managers tell them to do. That's what their bosses tell them to do. A development team is out there to build new features, new services, new products, whatever it might be. Build stuff, get it out there. There's a product backlog. You get the product backlog built. You look at what your customers are doing, and then you get back and you build more stuff. Go, go, go. Again, going back to a classical organization, we then have an operations team. And the operations team is often a completely different team in a completely different place with a completely different manager, and they are responsible for maintaining the quality of services and maintaining the things that have been built. So you've got these two different teams, and this is the root of the DevOps problem. These two teams are fundamentally in conflict because the biggest cause of instability in systems, if you look at any survey, any statistics from any organization, is change. The first root cause of any failure, any outage, is most likely to be a change in something. So I have a team here who have been told you need to change things, and I have a team here who have discovered that change gets them into trouble. And this is the root cause of the problem. in many, many organizations. And if I kind of go backwards and forwards like that, I discovered I could do this last night. It's really entertaining. This is like every project I've been on. That's me just getting my head kicked in by someone. So yeah, this is development operations, and it's unfair. It's really unfair because the people who are working in these two different groups, they're not the ones who set this process up, but they've been teed up against each other. The whole structure is set up so that they have completely mutually incompatible goals. For one of them to succeed, the other one has to fail. That's the problem. And this is the casus belli for the secret war that goes on in organizations. A casus belli is a reason for war. And this is the secret war that's happening, and it happens in so many organizations. And many organizations will say they don't suffer from this, but if you go and you work with the people, you chat to the people, you'll see that this happens all the time. So I'm going to illustrate this secret war with some examples. So here we go. This is a highly accurate and detailed and scientific chart of tension against time. Like I said, I work for McKinsey. You know, my presentations are really top-notch here. This is what people pay for. So what happens first of all? Someone comes up with a great idea. A development team build it, and they release it as a feature. And it breaks. Not every feature, but every feature, it breaks. So it breaks, something goes wrong, people want to know why it's broken. Ops discover that something was wrong with the deployment. They tell the development team, you didn't do this right. Development team, okay, sure, we've learned. They release another feature and it breaks again. By this point, the business stakeholders are starting to get antsy. We've spent all this money doing all this great stuff. You're releasing all these features and they're breaking. Everyone on Twitter is saying what a terrible job we're doing. What's going on here? So the tension levels are rising. So at this point, the first person who gets looked at when something breaks or goes down is the ops team. Why is it not working? Why is this feature not working? The ops team say, oh, well, this happened. But at this point, a lot of the people who are steering this project, they don't care. They're just saying, ops, it's in ops' zone. I don't know what they did wrong. And ops is starting to feel the tension because it's like, well, I was tossed something over the fence, told to deploy it and manage it. It's broken, and now I'm in trouble. So what ops do, and this is completely natural, is they start to set up processes to protect themselves. So if they got given something that wasn't properly tested, and they got their asses kicked, what they will do is they'll then set up a process which says, I'm not going to let you give me something unless it's been tested. So we start to build up a little bit of a layer of bureaucracy, and it sounds perfectly reasonable. We don't want people to be throwing stuff over the fence without it being tested. So we create these new processes. Anyone who's ever worked on any kind of development or product team knows what happens next. You just skip the processes. Like, I've got someone breathing down my neck. I've got someone kicking my ass. I need to get this feature out. So I'm just going to jugaad this and cut right through those processes because I've got to get it deployed. Like, I've got to do this tonight. So the processes get skipped. Something breaks. And then what happens is the ops team, they go to the next level. So this kind of Cold War is starting to escalate. So the ops team realized that processes were skipped, so suddenly things get locked down because, again, when it broke, they got into trouble again. They might have said that actually it was the development team's fault, and the development team will say it was the requirements' fault, and the requirements team will say, well, actually it was a full moon that night, so it wasn't our fault. But inevitably, the system then gets locked down. So these development teams can't cut through this red tape. So we're starting to increase more and more bureaucracy and more process. And this might be trying to build things that are more stable, but what's also happening is that the tension is rising between these teams. Already, ops and development are fighting each other. They're using paperwork, process, and bureaucracy as the weapons in their war between each other. So when the systems get locked down, the next thing that happens is that you just get a manager to sign off to cut through the red tape. I mean, I've been there. I'm sure many engineers have as well. We need to get this thing out. Oh, but there's this process. It's got to be penetration tested, and that takes 2 weeks. Yeah, okay, but if I get the CTO to sign this document, we can actually, we can skip by this. And they're like, oh, yeah, okay, you can. So we set all these processes and systems up. We cause a lot of conflict, and this problem's not going away. So the system's locked down, and now the feature's late. So now business weigh in as well. Anyone with a computer is getting stuff thrown at them. I don't care if it's ops. I don't care if it's dev. I don't care if it's a design. Just get it working. The tension's rising and rising and rising. Business go on the attack. They start looking to see who do we blame, start setting up more and more aggressive monitoring processes. Things are going wrong, so therefore someone must be at fault. Who is it who released this? Who is it who changed this? Now we're getting into an environment where change is becoming dangerous for people's personal health. There's so much tension around things breaking, there's so much tension around process and bureaucracy that people are starting to get a little bit scared. Why work on a complicated thing that's risky when you can kind of take it easy and maybe work on something that's safe? And then we keep on releasing features and they keep on breaking, because that's what happens. I mean, we know this is what agile is all about. We're going to release stuff, we're going to break stuff, and we're going to learn, and then we're going to do it better next time. It's an important part of what we do. So this is the challenge. Traditional organizations have separated the development and operations function so that change causes conflict. So whilst at a high level, we're saying to organizations, you should be more agile, you should test and learn, you should release things, you should change things. We've thrown all this oil onto this fire that's already been smoldering. And this has often been going on for decades. If you go to a large organization that has a technology function that's been around for a while, like a bank or a telco organization, they've had these departments set up for years. So this war is in like its fourth or fifth generation. People have been doing this for as long as their grandparents were in this war. They're not going to give up on it anytime soon. So a lot of people spent a lot of time thinking about how we could try and deal with this problem. And that's where the concept of DevOps came from. And it sounds very, very simple in practice. The idea is that the only way we can fix these problems at their root is by changing this source of conflict, which means we cannot have a team who are responsible for changing things and a team who are responsible for making things stable. We have to have a single team who are responsible for making stable changes. So, in the world of DevOps, we take these two units who are very unhappy with each other and we unify them. This is DevOps. The developers are happy, the operators are happy, everyone's in love. This team are responsible for building and maintaining new products and services that are maintainable and robust and stable. They have a shared and equal responsibility. They may have totally different skill sets still. Within this unified team, you still have the people who build and you still have the people who know how to maintain and operate, but they're part of the same group and they're incentivized in the same way. They are asked to build features which are stable, robust, and reliable. The operations team have as much incentive to bring new things out to users as the development team, but the development team also have as much incentive to make these stable and maintainable as the operations team. Because when something goes wrong, it will be a collective responsibility to fix it. This is the theory behind DevOps. DevOps is actually not about CI/CD, automation, continuous integration. These things are all very, very important. They're all tools that are in our toolbox to do with this. But at a very fundamental level, DevOps is a cultural change. It's about eliminating a source of conflict in organizations. And if anyone's ever worked in a large technology organization or a large organization that has a technology function, they've probably seen these conflicts happen again and again and again. And that can make an environment very unpleasant to work in. And unpleasant environments where people are scared of making changes or taking risks stifle any kind of creativity. And they're not fun to work in, they're not fun to be part of, and they're not effective. They don't do a very, very good job. Just gonna take a little bit of water. So, excuse me, that's the context. That's what DevOps is. That's where DevOps has come from. That's the problem DevOps is trying to solve. So why should we care? Well, why should we care? It's because of everything that I mentioned before about conflict and about change and about risk. Environments which are like this are not pleasant places to work. If we go back here, we see that change causes conflict. For most people, environments with lots of conflict are actually not very healthy environments. There are some people who seem to thrive on this kind of stuff, but for most of us, it's just not that much fun. So this kind of conflict leads to this. You have conflict, you have politics, you have bureaucracy, lots and lots of paperwork and processes, and you have intransigence, which just means an unwillingness to change. And for anyone who does work with large companies, this last one, intransigence, this is the one that the business should care about, because if you don't change, you're dead. Because the world is changing so quickly. If you're an organization who cannot change, you're in trouble. But for us, as product owners, as engineers, as testers, as designers, whatever it might be, all of this is boring. It's so horrible. Like, just let me get back to programming, or let me get back to designing, or let me get back to thinking about my users, because all of this stuff is just so boring to have to deal with. Yet it happens again and again and again and again and again. This is the kind of stuff that slows you down. It's the kind of stuff that gets in your way. And it's the kind of stuff that causes good people to leave organizations. So, back to the main topic, DevOps culture for engineers. This is the theory behind DevOps. The actual execution to make this work is phenomenally difficult. It's really, really hard, and we'll talk a little bit about why that is. But the main point of this presentation is to suggest some ideas for what all of us as practitioners can do to help our organizations move down this path, or start thinking about it, or work out what it is from these ideas that will work for our organizations. So, the first thing that I would suggest is a very simple one: learn about this stuff. There is some tremendous material available that's been put together by some really, really smart people who've been doing this with organizations for a long time. But we're never going to be able to solve these problems unless we start to become familiar with them. These are the 4 books that I think are probably some of the most useful for this. For anyone who's a practitioner, who works on a technology team, who wants to understand kind of how this works firsthand, I would suggest the DevOps Handbook. It's based on a lot of case studies about how organizations have actually done this. It's got some really interesting stuff in it about things like how organizations have been slowed down by technical debt, how LinkedIn stopped doing any development for 3 months while they completely restructured to solve this problem. It's got some fantastic thinking in. It also talks a lot about lean manufacturing, and in a fascinating way, a lot of this thinking came from industry. So in the US, car manufacturers were building longer and longer assembly lines and bigger batches of cars. In Japan, they completely went down the other direction and went for smaller, faster batches that they could change more quickly. This became what was known as lean engineering, and was a lot of the thinking behind DevOps and change and constant change came from this. The DevOps Handbook is a great one for practitioners. Now, for your bosses, for the people who are maybe less technical, but you want to educate about this, there's a fantastic book called The Phoenix Project. Has anyone read that book? In that case, I would suggest grab a copy, or ask your company to buy a copy and share it around. It's a really weird technology book because it's a novel. It's a fictional story, and it sounds like it shouldn't make any sense, but it's a fictional story about an organization that's going through all sorts of problems, and these problems are characterized as people. Stories are the best way of explaining some of these concepts. This book is an ideal book to introduce to managers or executives or people who are maybe non-technical, who when you say DevOps or CI/CD, they kind of go, This is the book to tell them about why it's actually important for organizations, for organizational health and productivity. For people who do a lot of building and engineering and who love programming, there's a superb book, Jez Humble and David Farley, called Continuous Delivery. It's a little bit older now, but it's the book that produced a lot of the ideas which became the cornerstone concepts of the technology around DevOps. So everything around building things quickly, automation, continuous integration. And then the last one, which I think is a fascinating book, again, for both business people and non-business people, is Google's book, Site Reliability Engineering. This is a set of essays that have been put together by Google's site reliability engineers. So these are the people who are essentially like the ops team, the systems administrators. Google's model is not a classical DevOps model of single unified teams. They have a much more nuanced model. But this book is full of real-world examples of things failing, teams working out how to make them more robust another time, or teams working out how to solve problems such as, how do we look into the root cause of an incident, which is often called a post-mortem, without making this a blame game? Because looking into an incident, why something's gone wrong, and understanding the root cause of that is critical if we're going to learn how to do a better job next time. But it can also quickly become a very, very damaging and toxic thing to do if you have a bunch of people pointing at each other and going, no, it was that person over there. No, it was that person over there. Yeah, this is important. So if you want to be a change agent for this kind of stuff, pick one of these books and start to read through it. I would suggest that these two are the most specific about that. All of the authors of these books, by the way, they are all regular conference speakers. They're all over the world talking about this stuff a lot. The next thing, once you've armed yourself with some of this knowledge, is to start to share it with people. but not only to share it, to get ready to learn. Because one of the things that people often say, DevOps is great, it's going to solve all these problems, we just take these teams and merge them together. And they forget about the obvious complexity, which is that just means it's a hell of a lot more to learn. If you're going to have your developers and they're going to have to start doing systems administration and maintenance, suddenly all of these programmers have to learn about a whole bunch more stuff. And if you're going to take your sysadmins and they're going to have to learn a lot more about development, they have to learn a lot more stuff. This is a tough ask for any organization. You're taking two groups of people who already have very specialized, very specific skill sets, and you're asking them to learn a ton of extra stuff. So getting people to teach each other is important. There's a lot of stuff which is at the intersection between these groups, which both will inevitably have to learn about. Now, this is going to vary from organization to organization, but I see that there are common things that go in the middle. It's probably not going to be the case that your Java engineers are going to have to worry about racking and stacking, or that your operators are going to have to learn about things like code quality metrics, but probably everyone's going to have to learn a lot more about things like versioning, HTTP, containers, container orchestration, a lot of the stuff that we're seeing spoken about today. So building an organization where we learn from each other and we're open to learning is very important. This is a very simple one, but it's very important. This kind of transformation, this kind of cultural change which happens in an organization is very, very hard for people. Often it happens at different paces in different parts of the organization. Change is difficult for people. People will still be being pushed into doing things in a traditional way, or they'll be expected to do things in a certain way. And this can be hard. So the next time, and this is something that we can all do, the next time someone pushes you back when you ask for something, or someone reacts negatively to something that you're proposing or doing, take a step back and try and understand why it is they're doing that. If someone pushes back and says, no, I don't want to deploy this over here, I'm not going to do that, and there's a very, very hostile reaction, it's easy to get hostile back. But if we take a step back and think about why is someone having the reaction like this, you will often realize that there's a lot more going on. This might be the 5th request they've had in the last hour to do something. They might have 6 or 7 different people breathing down their necks trying to do stuff. They might have a whole bunch of other pressures as well. And as we start to empathize with people and their challenges, we're much more likely to work with them to help them solve their problems. As you learn more, as you teach more, as you get more familiar with the subject and you get better at sharing it with your colleagues, the next thing to do is to fight for institutional learning. So institutional learning is when your organization actually invests in learning and makes it important and makes it part of their agenda. This can be all sorts of things. It could be allowing people time to work on open source, online courses, certification, meetups, conferences, whatever it might be. But this is all very, very important stuff. And I say fight for institutional learning because people do have to fight for it. I was working with a client a little while ago, and this awesome developer from Vietnam, who was from a very small company, was sitting there studying at the end of the day. And I went over and I was chatting to him, and he was saying, oh, I saw that you'd done this certification online and I really wanted to do the same thing. And I chatted to this developer who was studying in his free time. He was paying for the study material himself, and he was paying for the course himself. And if you're in an organization when that's happening, that is messed up. This person is making himself more educated, more capable, more expert, doing it off his own back in an organization that's making a load of money from people's expertise. You might have to fight for institutional learning, but it's worth fighting for. Because in technology, if you're not learning this new stuff, you are moving backwards. The skills that I had 10 years ago, I can't use them actively every day anymore. I would really like it if I still spent a large part of my time doing C, but it's no longer the case that I do that all the time. A lot of this stuff I've learned is still useful, but if I'm not learning the new things, I'm moving backwards. And if you're in an organization where learning is not given a sense of importance, honestly, leave, because they have the wrong vision, the wrong direction. Any organization that doesn't have this, give them a chance, push for it, ask for time, ask for money, but if they don't give it to you, move on. Because technology and what we're doing is all about learning, and it's all about change. The next one, this is a very practical one, and this is a fun one, particularly for anyone who does any kind of programming or engineering. I don't think anyone's raised their hand for anything today. I'm going to try one last time. Is there anyone here who does any kind of programming or development? Yes. Oh yes. I got a wave of hands there. This is the fun one. One of the great things about DevOps is it allows us to do some stuff that's really fun, which is to automate. So we end up having to do a lot more stuff. There's all these changes happening, all this operational stuff that's going to go around it. The only way for us to cope with this increased level of change is to automate things. If we're going to go from deploying one service to 20 microservices, there's too much work to do it by hand. So we automate. There's a really beautiful graphic which comes from XKCD. And this can be something that you print out and stick on your wall, and I'll walk you through it. So, how long can you work on something over a period of 5 years to save time? So imagine a 5-year window. If I do a task every month, which is here, and that task takes me 1 day, so 1 day a month doing a certain task for 5 years, I could spend up to 8 weeks automating that task and still save time. So anytime you see toil, and toil is activity which has no strategic value, it's boring, repeatable stuff, which is just junk you have to do, filing receipts, whatever it might be, stuff that's not really helping the organization. Look at this chart and think, what can I do to automate it? Because automation and working together with different parts of the organization to find ways to make stuff automated is actually a huge part of how DevOps is enacted in practice. We have to automate things. So this can be a really, really useful chart, and it can be fascinating how quickly a task that you only do, say, for 1 minute every day, it's surprising how quickly it becomes worthwhile actually spending the time to solve that problem via automation or by fixing it there. We've only got 5 minutes, and there's not as many programmers in the room, so I'm going to skip past the observable systems one, which is much more about the technical aspects. But I'm actually doing a presentation in Bangalore in a couple of months on exactly this, how to build things in such an environment. I think the last thing that I would say on this topic, which is the thing which is important, is for all of us, if we care about this, to elevate the discussion. So don't complain about the conflict between ops and dev, or don't complain about the management structure which has set this up. Elevate this discussion and have the discussion. Make this an important topic. Put it on people's agenda. If you're seeing this conflict, or if you're seeing the lack of investment in this, talk to people about it. Explain what could be done to change it. Use all of this new learning that you've got to suggest new ways of trying things. And it's going to be different for every company and different for every organization. But this is stuff that we all can do as practitioners every day to create healthier environments to work in, and environments where we get to use our skills and our creativity more. And on that one, I'll say thank you very much. This is what you can end up with. Lots of happy people working together, less conflict. And that's it. I'll open for any questions. Thanks very much, everyone. Thanks. Sorry, there was one question over there.
Yes, sometimes I see, you separate the complicated and complex. And I see in my organization there is a blue guy which are Waterfall and the red guy that are agile and we like to fight.
Yes.
But sometimes the systems are both complicated and complex.
Yes.
How do you reconcile both parties? We need to embrace change, but maybe we do a bit more than a sprint zero preparation.
I think that's an absolutely excellent point. So I'll yell it out in case anyone didn't hear the question. How do you work in an environment where you have both complex and complicated systems? And often this will be an environment where you have waterfall and agile. It's an excellent question because most serious enterprises will have a degree of both. So for example, if you're working with a telco business, the radio towers and the transmission of data from radio towers is very much a complicated problem. There is a known solution for how to move data across cell towers. The digital experience a user has when they work on their mobile app is a complex situation. I think first of all, being able to recognize which one is which is very important. Changing software in 400,000 radio towers could be a monstrously difficult job, and getting that wrong could have a colossal impact. So I would say that in this scenario, blindly assuming that, for example, waterfall is wrong, or waterfall is right, or agile is wrong, or agile is right, is the recipe for disaster. It's about recognizing the domain that you're in. The more complicated the domain, the more likely that good planning will actually help. But the more complex the domain, the more likely you're going to need to evolve and learn. And as you said, most organizations, particularly ones that deal with, say, specialized machinery or specialized systems, will have a certain number of complicated systems as well. But a lot of this thinking of DevOps and so on has come from a kind of startup culture where often things are very ephemeral and organic and quick, where they don't necessarily have to deal with as many of the old kind of machinery as there was there. So when I do things like architecture diagrams, I will often point at various systems and describe them as, are these industrial systems that are very much in this domain, like a mainframe banking system, or are they organic, complex systems? And there are still many things we can apply. I've seen teams do DevOps and continuous integration on AS400s, and I've seen agile work in core banking, but it has to be tailored to your needs. Super. Oh.
In an organization, right, we run by projects, and we sort of for this project, it's a Devops team. But eventually, this project will be completed. Right?
Yep.
Then how would you see to continue this project, to let this keep running for the next, let's say, 2-5 years? So are you, in Devops, is it the same people that build this will continue doing the maintenance for the next 5 years?
Yeah, that's another super question. So again, I'll yell out the question for the purposes of the recording. If we're in an organization where we run projects and project teams form, build something, and then disperse, how does this work? Does the same team maintain it and operate it? So it's a tough question, but the question I would ask is, why do you form project teams and then disband them, assuming that the work is done? Or this is what I would often ask the organization. I was working with an organization recently who wanted to build a certain product or service, and they were talking about doing this. But once they've built the product or service, it's not going away. And actually that product or service will keep on changing as they learn about their users. So if this is a product or service which is, say, public facing, it's actually going to keep on changing. So the idea of a project team that forms, creates, builds, tosses it over the fence and disbands, in many ways doesn't actually apply to real world systems. You might spend 10% of your time building a system, but 90% of its time is it's there in users' hands being worked on and adapted afterwards. So practically, it's difficult to keep a full-size project team going. The way I've often seen it work quite well is that you have guilds of different types of people, engineers, architects, DevOps specialists, and so on, and they will collectively form to work on a project, and then when the bulk of the work is done, the team might get a little bit smaller. People go back to their kind of home towns or their home areas, and then they might work on other projects, and we keep on cycling people in and out. So another example of this would be organizations who don't have enough ops experts to put DevOps people on every team. If you're in that situation, one thing organizations might do is have a central DevOps function, but they are like consultants. They get seconded to other teams. So whilst there might only be, say, 13 DevOps experts in the organization that might have 13 active projects, one person will spend Monday through Friday working with a product team, really incentivized, same team, same goals. And then on Friday, they come back to the central group, they share their learnings, they absorb what the others have seen, and then take that back the next Monday through Thursday. But again, it's going to vary from organization to organization massively, and there is no tried and tested method of making it work. It's about trying things out, experimenting and learning. Thanks very much, everyone. Thank you.